After looking at properties of radicals and how to simplify them, we're going to switch gears a little bit. But I decided to include this lesson in the same week as the one for radicals because it's not really, you know, different from what we talked about when we were graphing quadratic functions. So it's just a very quick, lesson or review of um, the different techniques that we used when we were graphing quadratics. So this chapter, our focus is on how to solve quadratic equations, and the very first method that we're going to look at is graphing. So I thought of, creating this foldable. I know I'm missing making foldables in the classroom already. So I have here a picture of my foldable. Um, I created this to summarize the methods that we will be studying this chapter, and I thought that it will be, a good takeaway that you can, use even when you are in Algebra 2 or Geometry next year. So it's like a handy tool that you can refer to anytime that you need to, um, recall some of the old topics. So if you don't have materials at home, you could just improvise or just write down notes, as usual on your notebook. So what I did was I just cut, I think this is six, little pieces of paper. I don't have the blank colored ones, so I use whatever my daughter has. And then I just taped them to a page of my notebook. So to create this effect of, having them layered, just tape the very first one at the bottom. Okay, so tape this one first, and then just stack the papers up like neatly, one on top of the other. So you can, open each flap every time you need to write on the next page. Okay, so the title of this chapter is Solving Quadratic Equations, and the first cover or the cover page of the foldable here explains what it means. So by definition, it's actually just, a process of looking for the value or values of x that will make your equation true or equal to 0. And those values are called solutions, which, if you recall, can also be called roots or zeros. Now, real number solutions can be found by graphing the equation and finding its x-intercept. So pretty much they are called solutions, roots, zeros, and lastly, if you look at the graph, they are just the x-intercepts. So here are some examples. If you look at the example, you have to change every equation to standard form. So in other words, the right-hand side has to be 0. Collect all the like terms on, one-hand side of the equation and try to arrange them from highest degree to the lowest degree. Now, some equations may only have one solution, such as in this case, while some may have two, so they intersect the axis 2 times. However, there will also be instances when the solution or the equation has no solutions at all. For example, this one, it has a vertex, but since this is not on the x-axis, it's not classified as a solution. Now, here you have a y-intercept, but it's not an x-intercept, so it's not considered a solution either. This is a counterexample because that's a linear function, right? Okay. So our focus for, this last 2 days of the week is how to solve quadratics by factoring and or graphing. So why did I put them together? Move on to the next page in your Schoology. So I put them together because this method, solving equations by graphing, works best for factorable polynomials. So for example, if you have binomials that are of the form ax squared plus bx is equal to 0, and that's factorable, you can easily find the zeros, okay, by factoring it and setting each factor to 0. Then you can, easily find the x-intercepts or the solutions. It also works for trinomials that are also factorable. And last but not the least, if you remember this from the last chapter, the intercept form of quadratic. So since it is already in factored form, then you can get the values of p and q for the solutions of your equation. Okay, so here's this example. How do we use factoring or grouping to solve quadratic equations? First, let me repeat that we have to change the original problem to standard form. So see what I did over here. I moved the 3 over to the left-hand side, and I put 0 on the right. Okay, so after that, we factor it completely. We can use the x method to factor this, or, a lot of you for sure know how to do this in your head already. So just think of two numbers that multiply to -3, and when you add or subtract them, you get +2. So in this case, 3 and -1. Then use the zero product property after you have factored the equation completely. So this is x plus 3 and then x minus 1. So using the zero product property, if I copy each factor and set it equal to 0, the first solution is -3 while the other one is +1. So how do I use these two to graph the function? So let's plot the x coordinates here of the, solutions. So -3 and 1. And note how I found the axis of symmetry. So we want to find the vertex, and we want to begin by finding the axis of symmetry. We know that the x-coordinate, or the axis of symmetry, is the point midway between the two intercepts, or the two solutions. So if this is -3, that's -1, +1. Find the middle value, you get -1, right? So we know that the vertex is along this line. So how do we know how far down here or maybe up there the y coordinate is at? Take this value, -1, and go back to your standard equation and plug it in. So let's say -1 squared is 1, and then 2 times -1 is -2. So 1 minus 2 is -1, and then -1 minus 3, so that will give you -4. Okay, so you're going to plug it in here in the standard form of the equation. So now we have found the vertex. So by doing this method, we're actually hitting two birds with one stone. So one, we were able to find the solutions, which are what we're after, right? The x-intercepts. And at the same time, we were also able to graph the parabola. So that's one example of, when to use this method. What I showed here is a trinomial that's factorable. Another example that we can look at is a binomial quadratic here, which has x squared plus 4x is equal to 0. So let's factor out the greatest common factor, which is x. If you divide both by x, you get x plus 4 for the other factor. So by using the zero product property, x is equal to 0, while here x plus 4 is equal to 0. So if you move the 4 over to the other side, then you will get x is equal to -4. So by factoring alone, you get your x-intercepts already, right? Now, if you want to show those solutions on the graph, then let's apply what we learned previously. Your solutions are your x-intercepts, so they cross the x-axis at that point. And then -4 is 1, 2, 3, 4, right there. Now, you can find your axis of symmetry in the middle, so that's x equals -2, and go ahead and substitute -2 here. So -2 squared, that's equal to, don't forget your parentheses, so that's equal to 4 plus 4 times -2, so that will be equal to, that's 4 minus 8, right? So that's going to be equal to -4. Now you can also get the same answer by substituting the -2 here. So if you get -2 and then -2 plus 4, these together will give you a +2. So +2 times -2, you would still get -4 as your answer. So the vertex will be, so assuming this is -1, -2, -3, -4, so somewhere there, that's going to be your vertex. So now you have a parabola that looks like this. There you go. All right. Now, sometimes the graph is already given and you're asked to find the zeros. So the zeros, or the solutions, will be the same as the x-intercepts. So you don't really have to solve. So just look for those spots where your graph crosses the x-axis. So take note, I'm not counting this point up here because that's not the x-axis. So the zeros here will be, or the solutions will be, let's write that down. You have -1, 2, and 3. And you can verify that by also factoring the original function. And last but not the least, there are instances when the solutions are not exact. So when does that happen? It happens when, the quadratic equation, the original equation, is not factorable. So you can't factor x squared plus 4x plus 1. So how are we going to find the zeros or the solutions? We're just going to give approximate solutions. So we're going to approximate what the possible zeros are. So the first one here at this point, we know that's between 0 and -1, but it's kind of closer to 0. So just use your best judgment. I'm going to approximate that to be around 0.4, right? Negative, while this one, it's between -3 and -4, but it's kind of closer to 4. So I'm going to approximate that as to be -3.6. So those are just possible approximations. Another way to verify your answer is to actually enter the equation in decimals. And once you are in decimals, you let your mouse hover over the points, and it will show you the coordinates of the actual solution. So in this method of solving quadratic, technology can be, very helpful. So whether you have a graphing calculator or you know how to use decimals, then you can use such tools to verify your answer.